So 5.3, we are going to study a particular distribution. And that distribution belongs to the discrete case, right? The one that we have studied earlier, the discrete probability distribution. And we call this binomial distribution, right? We will understand, we have some examples coming to help us understand that. Let's recall what we have previously, right? We had one example is try to list all the possible outcome, right? In terms of a gender, right? For the three children case, right? We are using the tree diagram to list all the possible outcomes, right? Could it be 3 boys or 2 boys, 1 girl, right? I mean, for each one, right? At the end, we are able to get 8 possible outcomes. And then out of those information, if we are asking, if I want to find out what's the probability to have like 2 boys, 1 girl, that combination, right? So that will be 2 boys, so you count. Out of each outcome here, right? Which of them they have 2 boys, right? So they have, like, you will see how many case? 3 case here. So that will be 3 out of a total 8. That is the probability getting 2 boys, 1 girl situation, right? 3 out of 8. That's the one we have learned before, right? If you know every single outcome, right? That's very straightforward. Now, tonight we want to use some other way to do that calculation. Think about the combination permutation we just learned, right? Previously, right? So we can consider we have a 3 position here, 3 position, right? We want to find out like 2 position here, and we want those 2 position to be boy, and then the other position to be girl. Is that right? That's the one we are trying to find out, right? So let's do that step by step, right, everybody? So let's see, we start with those 3 positions. Let's see, we want to select 2 positions. And then we want those 2 positions to be boy, right? Let's do that step by step. The first one, how many choice we have if we want to select 2 positions out of these 3 positions here, right? So in that case here, we consider this is what? You are choosing 2 out of 3, right? It is a combination case because we don't really, like, if, for example, if this is the case here, right? We don't really care like which one is the first one, which one is the second one, like that. If both are boy, we consider they are the same, right? If both are boy, we consider they're same. That's the reason you see this boy has only 1 case, right? We don't have another case here showing that. Okay, so that's you are choosing 2 out of 3, and it's a combination, right? That's how many cases you can get, right? With that choosing 2 out of 3. Okay, now you continue. Out of those 2 we selected, right? Say we know that many, right? For each one here. For example, this is 1 case, right? We want to those 2 cases to be boy. So in other words, what's the probability for those 2 positions to be boy, right? So we calculate what's the probability for this position to be boy? Half. What's the probability for this position to be boy? Also half. Follow me? We multiply them together. That is 1/4. So that's the probability for those 2 positions to be boy. And then we continue. We want the other position here to be what? To be girl, right? So what's the probability for this position to be girl? It's 1/2, right? So what's happening here is we multiply them together, everybody, right? We multiply them together to get the, let me see, to get what's the corresponding probability for us to get 2 boys, 1 girl, that output, that combination. Okay, so if you do the calculation here, you will get 3/8, the same answer as the previous calculation. Okay, so that's the benefit we are trying to introduce this new way to do the calculation here. Why we are trying to do this new way calculation? Because if we can generalize this situation, right? Let's use one more example. You will see how powerful it is to using some formula like that. Okay, let's study one more example here. Given some special coin, very special in terms of like probability of getting head is 60%. Probability of tail is 40%, right? So they're asking, find out the probability of getting 3 heads out of 4 tosses, right? So what does that mean? That means we are going to toss the coin 4 times. 1, 2, 3, 4, like that, right? So what do we do here? It's similar as what we did before, right? First we check, right? We want to select the 3 out of 4. Do we care about order? No, we don't care about order. So that's how many choice? That's this many, right? Combination, choosing 3 out of 4, right? Say this is one case here, right? That's one case. Here is hat, right? That's hat, that's hat, that's hat. You can choose any case with the 3 head, 1 tail, right? Say this is just one case and the other one should be tail, right? This is just one case. You can use any one here, right? To calculate now, what's the possibility for us to get 3 heads, right? On those 3 positions we select. That's the 3 position, right? So we know here's what? What's the probability for getting head? 60%. 0.6. Probability of head, 0.6. Probability of a head, 0.6. So it's 0.6 multiply 0.6 multiply 0.6. So we have 0.6 to the 3rd power. Everybody follow me? And then what's the probability of getting tail? Is what? It's 0.4. How many? It's only one time here, right? So 0.4, I'm writing this as 1 minus 0.6. Everybody? So that's the benefit. Like we can write down the formula directly. We can calculate the answer directly to find out what's the probability for us to get 3 heads, right? Follow me? So far so good, everybody? Using this formula here, right? So if you pay a little bit more attention here, right? So that's 3 is what? Questions?
Why is there a 0.4 again?
0.4 is the probability of getting tail. So what's the probability of getting head is what?
0.6, I see.
Yeah. So it's a very special coin. It's given here, right? So when we select 3, right? So select 3 out of 4, then it's 0.6 to the 3rd power. You see that one here? And then there's one left. This 1 is equal to what? Actually, this 1 is equal to 4 minus 3. You see? Now, if I change the question a little bit, everybody, if you want to care about the exam, right? Care about the homework. What's the probability for me to get 2 heads out of 4 tosses? I can write down the probability here directly, everybody. So what's the probability should be? If I want to find out 2 heads, 2 tail out of 4 tosses, the answer should be C, 2 out of 4, right? Follow me? And then multiply, we want to get 2 heads, is that right? So 0.6 to the square, 2nd power, is that right? Because previously we say 3 heads, then we have 3rd power here. Now we have 2 heads, that's square. Follow me? And then how many tail? Tail, we want to have another, because we have 2 heads, that means the other 2 should be 2 tail, is that right? What's the probability of getting tail? It's 0.4. And that should be 2, is that right? Follow me? So In other words, here, 2 plus 2 is equal to what? 4.
Why isn't it 0.6 for the tails? Because if there's 2 coins and there's 2 tails, 2 heads?
Um,
Or is it because it's a special coin that there's 3 heads, 1 tail?
is a special coin that we are asking if you toss this special coin 4 times, what's the probability to get 3 heads? That's the in the beginning, the first question. That's the answer, right? Now, I changed the question a little bit. Say, can you help me calculate what's the probability for me to get a 2 heads, 2 tail out of 4 tosses? Is that clear? So you toss the coin 4 times. What's the probability for me to get 2 tail, 2 heads?
What's given there, basically, or more options?
The only special information here is that is a special coin. Otherwise, you think about like you have a 1 coin, right? So you toss the coin 4 times. So each time you toss the coin, you get a head or tail, is that right?
Yes.
So, but you have to toss it 4 times though, right?
Yes.
And then you want to find out of those 4 tosses, what's the probability for you to get 2 heads, 2 tail? Is that clear?
Yes, 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 understood.
Okay, so that is the benefit. Using this formula, we just introduced that here, we can write down the answer directly. Okay, we can get the answer directly. In general, we have this beautiful formula here, everybody, this one here. So if we want to, let me erase that. I don't want you to get distracted. If you select X out of a total N, right? So in this case here, if you want to get X number of heads out of N tosses, right? So we are going to select X out of N combination. Remember, that's the one we have used previously, is that right? That's the one. C, like this case here, C3 over 4, right? Like Cx over N. Now, probability of head, that's 60%. Well, in this case here, we are using P for the probability of getting head, if the head is the one we are interested, right? So we have P to the X power, 0.6 to the third power. That is a 3 here. That is X here, X here. Follow me? And then we are using 1 minus P. So that's if the P is the probability of head, 1 minus P will be the probability of tail. Is that right? So we have this relationship. We usually use like Q to indicate that PQ is usually one pair. Everybody, let's see this one, right? So if this is the P, that's the probability of tail, a head, right? Everybody, if I'm asking you, right? P is 60%. What is the Q? What is the Q? Should be 40%. Is that right? Because the adding them together should be equal to 1. Everybody? So this formula here is a perfect formula for the 2 possible outcomes. That's tricky, right? 2 possible outcomes. You cannot have more than 2, right? So this case here, you have like, if you toss a coin, you can get a head or tail. If you take some class, right, you can pass or not pass, like that. 2 possible outcomes, like that. Is that right? So that's what they call binomial distribution. 2 possible outcomes. Okay, the formula here is right. We are using the X heads out of a total N tosses to show you what's the probability we can get. Everybody, if you kind of get confused for this formula here, right? It's temporary okay, okay? It's temporary okay for this formula. I'm not going to ask you to do the calculation using that formula, because that is requires quite some calculation, right? But as long as you understand binomial distribution, you only have two possible outcomes, right? Could it be a head or tail, right? Could it be a success or fail, right? Those two possible outcomes, right? Now the next question is, how do we calculate? Now, based on that spatial distribution, binomial distribution, how do we calculate average? How do we calculate variance? What do I mean by that is, now we know the probability of X. Remember, previously we have that table, right? If I can write on that, it's like you have X, you have PX, that probability distribution table. Remember? So in this case, for example, you toss the coin 4 times, number of heads could be 1, 2, 3, and then you calculate what's the corresponding probability here, like that. How do we calculate each probability? Plug each formula here. Like in this case here, X equals 0, plug that. X equals 1, plug that to find out that probability. And then how do we find out the average, right? That's the tricky part, right? So before we go for the average, let's have some example here so you understand what I'm talking about here. Okay. Going down a little bit. Okay. So for example, if I want to find out what's the probability for me to get 3 heads out of 4 horses, but it's at least 3, right? It's not only exactly 3. So that means I need to find out the probability for me to get 3 heads, as one case, or probability of 4 heads. Do we have to add like a probability of 5 heads? No, because only 4 tosses, right? Because it's at least 3 heads. So that could be 3 heads or 4 heads. We don't have 5 heads here. And then we plug each number here, right? We plug each number here to the calculation. Everybody, this will take some time, right? That's the reason we don't require that, okay? So we can temporarily skip that if that worries you, right? No, you don't really have to worry about that. But I do want to mention the tricky part is you can imagine using this formula to do the calculation. It's not that easy, right? Like even in each case here, you try to add them together, not that straightforward, right? So it turns out, questions?
Yes, please.
Yeah.
Pardon me. So how is that formula, like the P3 plus the P4, P plus Q, how is that different from the previous formula above the P plus Q?
This one here?
Yes.
Okay. So we are using, tell me that if P is equal to 0.6, what's Q?
It's P equal, sorry, 6, then the Q is 4?
That's right, 0.4, right? So that's the reason you see, you always have this relationship here, P to the third power, and then the 4 minus 3 is equal to that 1 here. And then you are using, because we handle the number of heads here, then we handle number of the tail.
Yes, but what is the purpose of these formulas? What is the target goal is trying to get, so that I wouldn't get confused about which formula I need to select?
Yes. The formula here is to tell you, you can write down the probability directly. If I'm asking you, right, for this special coin, right, I tossed the coin 4 times. Help me find out what's the probability to get 3 heads. That's the answer. Now, if I change the question, I tossed the coin 7 times. What's the probability to help me get 5 heads? What's the answer should be? Can you help write down the answer?
For that equation, for that.
Yeah, should be select 5 out of 7. Is that right? Previously, it's like a 3 out of 4. Is that right?
Yes, yes.
Yeah. So, and then what?
Times
Continue to multiply.
times
What's the 0.6?
p to the power of
P to the power of which power?
5.
5. Right, exactly. And then we are using 1 minus P, that's 1 minus 0.6, right? To the which power?
The n minus x, which is 7 minus the 5.
Minus 5, exactly. You see, which is equal to 2, is that right?
Mm-hmm.
So in other words, if I ask you that question, help me find out the probability of 5 heads out of 7 tosses. I tell you the answer right away.
So with that question that was given, find the probability of getting 3 heads out of 4 tosses. It goes to that using that formula. So the formula underneath where it says n factorial, etc. Well, what situation does that formula apply to?
That's the formula, the combination formula we learned previously. This one is equal to that.
Oh, okay.
Yeah. So that's the one we, sometimes we may require that, but not particular for this section. Yeah. Any other questions?
Just last question, please. For where it says P plus Q, I just want to get an understanding of how does that situation differ from the question of the probability of getting 3 heads out of 4 tosses. I guess that the question above where it says 3 heads out of 4 tosses is one possible outcome, whereas the one underneath is asking for 2 possible outcomes. Am I right?
I didn't get your question, sorry.
Meaning like the first question has to do with one case, and the second question has to do with 2 cases, which requires me to use the P plus Q formula.
First case, we are talking about which one?
Where it says the quote, find the probability of getting 3 heads out of 4 tosses.
Okay.
I believe that's one case, like one situation.
Okay, and what's the other case you are mentioning for the second one?
Down where it's, yes, there we go, where your mouse was.
This one?
Yes, right here. Where it says only 2 possible outcomes.
Okay, the 2 possible outcome is to deal with, you toss the coin. What's the outcome you are getting?
I think you would need another coin.
No, it's on each toss. Since the coin is weighted one way, there's only 2 possible outcomes when you toss a coin because there's 2 sides.
Mm-hmm.
That's what it means.
Mm-hmm. Oh, okay. So there's no 2 coins then. It's just one coin with 2 faces.
Each time we are talking about one coin, right?
Mm-hmm.
But with this, here we have to toss the coin 4 times, right? So that's the reason each time when you have this event, you only have 2 possible outcomes.
And the weight is changed towards heads, so that's where you get the 60 and the 40 from.
Yeah.
And then where it says 2 possible outcomes, meaning 2 tosses instead of 4.
No.
No, one side of the coin and the other side of the coin.
Okay.
That's your 2 possible outcomes, heads or tails.
Thank you. Is that clear or still confusing?
It is clear.
Okay. Yeah. Thank you. Now, so that is the beauty using this formula, right? We can write down any answer right away. Now, the part I mentioned, if you want to do the calculation, will take some time, right? Even though we know the answer, right? We know we can plug into the calculator to do that, right? But it will take some time, right? Given that probability distribution, everybody, this is the way to help us. What is the probability for, capital X equal to, for example, capital X equal to 3, right? You plug in, you got that. My question is, how do we apply those to find out what's the average, what's the variance for this special distribution? this special distribution in terms of you only have two possible outcomes. So it turns out there's a relatively short formula. We can apply that directly. We don't have to worry about like using this formula we just learned. Everybody, that one, right? The average is we have to do that. The variance, we have to do that, right? For this special distribution, everybody, this formula here is only for binomial distribution. Okay, it's not always, this result here not always right. Only for binomial distribution, you can apply that, right? This formula here, it is always right, but if you want to use this way to do the calculation, will take you forever, right? So that's the reason we want to introduce a shortcut to find out what's the average, what's the variance, right? I think right now still is a little bit confusing, right? Let's use some example to help us understand better. Like how do we apply this formula? What does that mean? Okay, otherwise I would say some people will have some questions, right? Let's use some example to explain that, okay? This example here, let's see. So you toss the coin 4 times. Everybody, each time, if you toss the coin, I mean, they didn't mention anything about special, right? Anything special about that coin by default, like half and half, is right? So you can get either head or tail, right? So you toss the coin 4 times. So how many times total? That's n is equal to 4, right? You see? Now, you want to find out what's the average. So in other words, you toss the coin, regular coin, 4 times. Help me find out the average to get the number of heads. Is that clear? That's the question, right? Help me find out, on average, how many number of heads I'm getting, right? So because each time when I toss the coin, I can only get either head or tail, 2 possible outcomes. That'll give us apply the binomial distribution formula. The average, whenever we talk about average, right, that's this mu here, is equal to what? Is equal to n multiplied p, everybody, right? So what's n? How many times you toss the coin? So you toss the coin 4 times, okay? And then what's the p? P is the probability that, because you are interested in number of heads, right? So p is the probability of heads each time. Each time you have half. So 4 times multiply half, you got a 2. So what does that mean? That means you toss the coin 4 times, everybody. On average, how many number of heads you are getting or you are expected should be equal to 2. I mean, that's intuitively reasonable. Is that right? So that's the case we, 4 multiplied by half is equal to 2. That's how many number of heads on average we are getting, right? Variance, sigma square, so we can apply that formula here, n multiplied p multiplied by q. Okay, so what is n? How many times? 4 times. What is the p? That's the probability of head. That's the one we are interested. Q is the probability of tail. Remember, it's like 1 plus p plus q is always equal to 1, right? So we multiply them together, we equal to what? Equal to 1. That is what? Variance. And if we are asking what is the standard deviation, that will be square root of 1, which will be also 1. Follow me? We spend some time to answer the question. I don't have that much time left. Okay. Give me 2 more minutes. We can finish that one here. So a die is tossed 480 times, right? That's the n. That's the n here we have. The trouble here is if you toss a die, everybody, what's the possible outcome? You have 1, 2,
1, 6.
Yeah, 1 to 6, right? 4, 5, 6. Then we got a trouble. Why? Because we are asking binomial, when you apply the binomial formula, you can only have two possible outcomes, is that right? But here, if you toss a die, how many outcomes we are getting? We are getting 6, is that right? We cannot apply the formula directly, right? If it's based on these 6 outcomes. But if we check the question here, everybody, they're asking, they want to find out the average in terms of the number of 3 that you are getting. So what does that mean? That means you can break this 6 outcome into 2 outcomes. What are those 2 outcomes? Is the number of the ones with 3 and the number of the ones without 3. You see what I mean? So in other words, we still break that into 2 categories, 2 possible outcomes. You get a 3 or not a 3. So you combine the other 5 pieces here together as one case, as one outcome, right? You have a different probability, right? So if you toss a die, what's the probability for you to get a 3? 1/6. What's the probability for you to not getting 3? So you have 5/6. Follow me? So that's the Q. That's the Q, right? Here is the P, right? So we apply this mu is equal to n multiplied by P, we got 80. What does that mean? That means if I toss the die 480 times, on average, we are expecting 83. 83, right? Now, the variance is equal to n multiplied by P multiplied by Q. So you do the calculation, you got that. All right, so as for this case, it's a little bit tricky because we want to convert, right, 6 outcome into 2 outcome. And then we can still apply the binomial formula to help us solve that. I hope it's clear. Now let's move on. Last example here is the twins, right? So we are given the information that about 2% of a birth, right, is twins. 2% of the births are twins, okay? And then we're asking out of 8,000 births, find out what's the average number of births to be twins. So what does that mean? Like out of those 8,000 births, on average, can you tell me how many of them will be twins? Like that, right? So in this case here, we are given the P is what? Probability to be twins, 2%. So what is a Q? Q is equal to 1 minus P, right? 1 minus P. So that means is probability of not twins is 98%. Is that right? So we are using 8,000 multiplied 2%, we are getting 160. So in other words, out of the 8,000 births, we are expecting 160 to be twins. How do we get that? We are using the binomial distribution formula, right? The variance is n multiplied by P multiplied by Q. To multiply them together, I have dot here, you can calculate